Question 7, the equation of a curve is y equals to 2 plus 3 upon 2x minus 1. In part 1, we have to obtain an expression for dy dx. So in the first step, we can write the equation as y equals to 2 plus 3 into 2x minus 1 to the power minus 1. Finding the dy dx, differentiating 2, that will become a 0. So that will be 0. Minus 1 into 3 will be minus 3. And this will be 2x minus 1, decreasing minus 1 by 1. So that will become a minus 2. And multiplying it with the derivative of 2x minus 1, so that will be 2. Simplifying this, the dy dx will be equals to, so minus 3 times 2 will become a minus 6, and we can bring the 2x minus 1 to the power minus 2 in the denominator and write it as 2x minus 1 whole squared. So the dy dx will be minus 6 upon 2x minus 1 whole squared. In part 2, it says explain why the curve has no stationary points. So for stationary point, the dy dx is equals to 0. So if we write 0 is equals to minus 6 upon 2x minus 1 whole squared, this whole term will multiply by 0 and this will become a 0. So we can say that there are no values of x for which the dy dx is 0. So we can also write that this is not possible. So there are no stationary points on the curve. In part 3, it says at the point on the curve x equals to 2, show that the normal to the curve passes through the origin. So in the first part, you'll have to first find the equation of the normal. Now, to find the equation of the normal, we'll first have to find the gradient of the tangent. So we already have the dy dx, the value of x is 2. So first finding the dy dx when x is equals to 2, so that will be minus 6 upon 2 into 2 minus 1 whole squared. So that will be equals to minus 6 upon 3 squared, which is 9. So this will be equals to minus 2 upon 3. As dy dx gives us the gradient of the tangent, so the gradient of the tangent is minus 2 upon 3, which means that the gradient of the normal will be equals to positive 3 upon 2. Once we have the gradient of the normal, we can form the equation. As the value of x is 2, so we can substitute x equals to 2 into the equation to get the value of y. So y is equals to 2 plus 3 upon 2x minus 1. Substituting x is equals to, so this is 2 plus 3 upon 2x minus 1. Substituting x equals to 2. So y will be equals to 2 plus 3 upon 2 into 2, 4 minus 1. So this will be 2 plus 3 upon 3. 3 upon 3 is 1. So y will be 3. So once we have the coordinates of x and y coordinates are 2, 3, and the gradient is 3 upon 2, we can form the equation of the normal. So the equation will be y minus 3, y minus y1 is equals to m into x minus x1. So x1 will be 2. Cross multiplying, we'll get 2y minus 6 is equals to 3x minus 6. Taking minus 6 on the other side, the equation will be 2y is equals to 3x, as minus 6 plus 6 will be a 0. So y will be equals to 3 upon 2x. Now substituting, when the value of x is 0, the value of y will also be 0. So it shows that the normal to the curve passes through the origin. In part 4, it says a point moves along the curve in such a way that the x coordinate is decreasing at a constant rate of 0.06. We have to find the rate of change of y as the point passes through P. Now, the x coordinate is decreasing at a constant rate of 0.06. It means that dx by dt will be written as negative 0.06. We need to find dy by dt. So the formula relating dy by dt and dx by dt is dy by dt is equals to dy by dx multiplied by dx by dt. Now we already have the dy by dx at point P. So at P, the dy dx was equals to, as we found in the previous part, that was equals to minus 2 upon 3. So the dy dx was equals to minus 2 upon 3. Finding dy by dt, so that will be equals to, so dy by dt will be equals to minus 2 upon 3 multiplied by minus 0.06. The negative signs will cancel out. Simplifying this, the final answer will be 0.04 for the rate of change of y.